Hey everyone, in this video, I will be comparing the Uno R3 with the new Uno R4 boards. And by the end of this video, you will have a clear understanding of which board to choose if you are confused. I will also give my final verdict at the end. So without any further delay, let's dive right into the comparison. The table here sums up all the differences between the two, so please have a quick look. So first things first, there are two versions of Uno R4, R4 Minima and R4 Wi-Fi. This is R4 Wi-Fi. Both boards are identical, but R4 Wi-Fi has some additional features, which are ESP32S3 chip giving it Wi-Fi and Bluetooth functionality, 12x8 onboard LED matrix, and an I2C connector. But irrespective of this, the comparison is valid for both boards. The Uno R3 that I have here for comparison is a clone, but closely resembles the original one. In fact, I never purchased an original Uno R3 because I never felt the need to. So let's start with the hardware differences between the two. Since both are from the Uno family, they have the same form factor, 68mm in length and 53mm in width. If you are a true Uno lover, then this may be a bummer for you. Unlike Uno R3, the microcontroller on Uno R4 is not removable. The fact that you could remove the microcontroller IC on Uno R3 made it very popular. Because I can replace the damaged microcontroller with a new one without the need to purchase a whole new board. Secondly, in a project where I need this Atmega IC only, I can program it by placing it here and then use it as a standalone device. Now I know some clones have SMD version of the microcontroller installed. I'm not talking about those here. The microcontroller on Uno R4 is Renesas RA4M1, a 32-bit microcontroller based on ARM Cortex-M4. And compared to the 8-bit Atmega 328P on Uno R3, it's very powerful. The clock frequency of R4 is 3 times than that of R3, running at 48 MHz. Programming port. A USB connector can be used to power or program the board. The new R4 has a better USB-C connector instead of the old bulky USB-B connector on the Uno R3. It's faster, more durable and easier to plug in since it works both ways. This is an essential upgrade as USB-C is very popular and commonly used nowadays. So no need to purchase a cable separately just for programming the Uno. Memory. Can you guess how much more memory we get with the Uno R4? Let's compare. Flash memory. 32 KB on R3, 256 KB on R4. 8 times more than the Uno R3. SRAM. 2 KB on R3, 32 KB on R4. 16 times more. And EEPROM, 1 KB on R3, 8 KB on R4, 8 times more. So overall you get 8 times more memory with Uno R4. And by chance, if you decide to go with the Wi-Fi version of R4, you get additional memory of ESP32 as well, 384 KB of ROM and 512 KB of SRAM. Now let's discuss the pins on both boards. Just like R3, on the right side we have 14 digital pins, out of which 6 supports PWM. No changes here, right? Wrong. PWM pins here can generate a 12-bit signal, unlike the 8-bit PWM signals on R3. The higher the resolution, better the analog output. But irrespective of the resolution, a PWM pin can never generate a pure analog wave. Why? Because it's still a modulated signal. We are just switching the digital output voltage at a very high speed with a specific duty cycle to get an average output value. And that's why R4 has one DAC channel as well. It's on pin A0 and has a 12-bit resolution, best for audio projects and generating different signals. Similarly, we have an increase in ADC resolution as well, from 10-bit resolution on R3 to 14-bit on R4, which provides better analog or sensor readings. Regarding communication protocols, the R4 supports UART, SPI, I2C, just like R3. But it goes the extra mile with support for the CAN protocol as well, providing new opportunities for advanced projects. Pin D4 and D5 are pins for the same. RTC. To keep track of the date and time of your project, you must have used this module called RTC or real-time clock module with Uno R3. You don't need this bulky module anymore. Yes, the R4 has a built-in RTC chip inside the Renesas RA4M1, which is very easy to use. To power the boards, you can either use the barrel jack, USB connector or V-in pin. The V-in pin on R3 accepts voltage between 6 to 20 volts and on R4 between 6 to 24 volts. But the recommended voltage is 7 to 12 volts for both boards. Another important difference to note here is the voltage regulator on R3 versus buck converter on R4. Both perform the same function, converting the external supply voltage to the rated voltage of the microcontroller. Since a buck converter is more efficient, they decided to use it in R4. Current consumption. In terms of current driving capability, these boards are not compatible at all because the maximum current limit per GPIO pin on R4 is 8 mA, which is 2.5 times less than that of R3. The same sensors, actuators or modules we have been using directly with UNO for years are no longer possible with R4. So even if you want to use an LED, you would have to be extra careful in choosing the resistor value. So where's compatibility there? Price. If you will compare the price on the official website, R4 Minima is priced at $20, whereas the R3 at $27, almost 25% less. Now it may seem Minima is the best option here, but we should consider this as well. You can get a clone version of R3 for just $10 at half the price of R4 Minima. So if you're a beginner just starting out, I recommend starting with R3 as it is more beginner friendly. Thousands of projects are made using it, and answers to almost all the questions and doubts related to it are already there on the internet. If you go for UNO R4 Minima, you will have a hard time figuring out how to build projects made on R3 using it, due to its low current driving capability and peripheral issues. As for the R4 Wi-Fi, it will cost you $27. By paying $7 extra, you get the Wi-Fi plus Bluetooth functionality and an LED matrix. But if you're really interested in wireless features, then it's better to go for a $7 ESP32 board. ESP32 has become very popular in recent years, and there are a lot of books, tutorials and websites on the topic. So why pay 4 times more for just the Wi-Fi feature? On the contrary, if you're an experienced user and have an existing UNO project requiring Wi-Fi or Bluetooth and a display, R4 Wi-Fi can be a good choice. No need to buy a separate wireless module when you are getting the ease and support of Arduino with the power of ESP32 on a single board. So guys, this was it. If you liked the comparison between both boards and are interested in more Arduino related videos, then please subscribe to the channel and I'll see you in the next video.